Hello and welcome to the session where we'll be looking at a different model for estimating risk. So to view it, let's first create a data table, and we'll still use the class results dataset and Control Enter as usual. And now if we head over to the operations available, we have this risk alerting model. So if we select this, then we again refresh fields, and this time we'll choose the student number. So although the title here says label, it's not really a label. We'll just use the student number as a handle because we're going to look at different student numbers and look into the results there and so on. So anyway, we'll see what that means just now. But let's just set that on student number. And then with the features, let's pick the first 3 tests to look at. And this is an example of an unsupervised learning model, or it's an unsupervised model. And in this case, the features are just these ones. Although we have specified a label, you can see the nature of the label. It's really, it's not classification that we're trying to do. So we pick 3 features, and it's a risk alerting model. That's basically it. So if we click on operate, then we can see this exciting area has opened up down here. So let's look at what this is. So in our data set, remember, we had specified 3 features, and we could have chosen any number of features, as many columns as we have. So we chose test 1, test 2, test 3. And it's computed here the normal distribution statistics around that. So it says there are 100 students. The maximum in test 1 is 112. So it's simulated data. So we allow ourselves a bit of free license there. Minimum mark 22, the mean mark 67, and a standard deviation of about 20. There's also this term, the skew, right? Skewness is a bit casual. So the skew. So how much is our data actually skewed to the left and right from a perfect normal distribution? And so I believe this one skews to the left, and because it's negative. And then kurtosis is how high is it in comparison with a perfect normal distribution. So you see, if you use the mean and standard deviation, you can generate a perfect normal distribution. Clearly, the orange dots here, that's a perfect normal distribution based on these values. And then our actual values. So if you take classes in between and you calculate the number of students in a certain range for that test mark, then you can estimate a number. And if you divide by the size of that class, then you can get the estimate of the value that's equivalent to the distribution value. So you can see these test marks do roughly approximate the normal distribution, but there are some differences. So these values give us a sense for how closely it does follow a normal distribution. And we can view that for each of the tests. So you can just click on this accordion type of thing here, and you can see how that departs. So those are the basic statistics. And what we have here are the actual results. So we can see high performing, at risk, and all. So high performing are those entities, right? This is a microservice. You could apply this to any data set. And in this case, we are looking at students, but you could apply it to some chemical process, for instance, and look at what are the high performing aspects and the low performing aspects. So if you click on view all results here for the student, so clicking on that, you can see here the student has accomplished these marks for test 1 and test 2. And it's showing all the other data it knows about the student as well. So it's showing the raw data here. It's showing a report it's created based on some metrics. So we can see here that test 1 Z, so it's worked out a Z value here. So the Z values are the number of standard deviations away from the mean. We can see for test 1, the mean is 67. So this student's mark of 94 is significantly above the mean. Well, significant because the standard deviation is 20. So this mark of 94 is 1.2 standard deviations above the mean. So this student has performed significantly better than the other students. And so it's useful to go this route, right? When we have means and standard deviations, that allows us to comment on whether or not it's significantly better than other students. So, for example, if we had a mean, right? Let's say that was our mean, but let's say there was an extremely high standard deviation that there were some students getting in the hundreds and there were many students getting in the low 30s, then we could say, well, then it's not clear whether this 94 is significantly high because there's such a wide scatter. But because the scatter is only 20, right, it's on average, that's the width of the distribution. It's only 20, then we can say, yes, in this case, that this is a significantly high mark. In a similar way, the student also has a significantly high mark for test 2. So overall, the student is doing fairly well. If we look at the at-risk, if you click here, view all results, then again, the student has 43, which is 1.2 standard deviations below the mean. So this student is significantly underperforming in 2 assessments. And so we classify this as being at risk. You can also view all the records. So you can page around here. You can use the filter and so you can just look at specific groups if you want. And you can page around through all the records here and look up the results. Right, so that's the risk estimation. You can also adjust the settings. So you could specify that we only define students to be high performing if they are more than, let's say, 2 standard deviations above the mean. And in that case, so if you adjust these and then you click update risk settings, then it will regenerate these lists of high performing and low performing and so on. So let's talk about what's in here. So minimum value alert. So this is where if we want to add an alert for a value going below a certain number. So let's say test 1, we can say here, yes, it's very clever. We're using the normal distributions metrics, but you could also say, well, I'm also worried about 50%. So you could, if you specify a number here, 50, then in addition to the normal distribution way, it will also look for if a student has a result less than 50% for test 1, then it will also add an alert in that case. Then this one says omit the low check if it's above a certain value. So if we are saying, let's say our mean value was extremely high. Let's say the whole class got marks above 80%. It would be a little ridiculous for us to raise alerts on a mark of, let's say, 70%. Let's say a student got 70%, even though the mean was 80%. Let's say the standard deviation was also low at 5. Then if a student got below 75%, we would end up raising an alert on a student who got 70%. So if we say, well, it's ridiculous to go and raise alerts if your marks are more than 70%, then we don't want to raise an alert. So you can specify that here. You can override the check for absolute marks beyond a certain value. And as we said before, we can also change how many standard deviations above or below the mean we raise alerts on. So we classify high performing when we are above the maximum standard deviations, and we start to classify at risk for below a -1. And then include zeros. That's if we suspect that there might be some issues in our data. If we suspect that a 0 is actually not a real 0, that maybe it's being absent on a test or there's some other kind of artifact, then we can say, no, don't include the zeros. Don't go and calculate standard deviations on zeros. So for each of the selected features, we can adjust the settings here. And then when we click update risk settings, then it will regenerate our lists here. So this is a kind of an unsupervised learning. So we can raise alerts on different features and the overall. So what the system does is it counts up the positive and negative alerts for each entity. So whether it's a student or whatever that data set is about. And so it raises alerts according to those criteria. And then it counts the number of positive and negative alerts. And overall, it creates a summary classification. So is this a high-performing entity or an at-risk entity? And it lists them accordingly. There is also a messaging aspect to this, so I didn't switch it on here, but you can also auto message all these people. So you want to encourage the high-performing students to keep doing well. You want to encourage the at-risk students to engage with support, right? It's important. We're not trying to discourage anybody. We want to just direct people to the right form of support. So that's your risk alerting. And again, we can obtain that risk alerting simply by in our data table, we go ahead and we just select risk alerting model. We specify the label. So remember, when we want to view the results with respect to a certain entry, we need a label there. So we specify what label to use, and then we specify the features to do the statistics on and operate, and that gives us the risk alerting table there. There are some quick links up here. So this gives you some summary statistics. So there are 100 students, 17 high performing, 18 at risk, and then the stats for the tests. Yeah, they actually don't look like the right values here. That's a little bug that needs to be caught. But otherwise, if you click here, it takes you there, click there, it takes you there, and so on. So you've got quick links to each of these things. Okay, so that's one of the models available to us under the table attributes. Thanks for listening.